Hello, Mr. Melo here, your online math teacher. Welcome to my channel. Today we're going to be continuing my video series on two variable statistics, and in particular, we're going to look at how can you interpret the slope and y-intercept of your least squared regression equations for data. So if you find this video helpful, consider smashing that like button, subscribing, and let's go. So here are some heights versus weights of different people I have, and I plotted them on a scatter plot, and you can see I drew in my least squared regression line. And I wrote my equation for it written down here. Now, your teacher might give you the equation of your least squared regression line like I have here, and it might be up to you to decide what number is your slope, what is your y-intercept on this least squared regression line. And you can think back to algebra when you learned the equation y is equal to mx plus b, because that is probably your favorite version of a line. So the slope is the coefficient in front of your x, or your variable, your explanatory variable here. So our slope is going to be this 9.2763. So we have a slope of 9.2763. Our y-intercept is the constant value. So it is not attached to the x. It is this negative 454.12. Now, we want to know, how can I interpret the slope and the y-intercept within the context of your data? Because in statistics, everything has meaning, everything has context. Numbers are not just numbers. If they are, you're not doing statistics, you're doing algebra and computations. So, let's think about this. Slope you can think of as rise over run, or your change in y over the change in x, if you think back to algebra. So we can ask ourselves, really with this graph, as I increase my height, so as inches increases, how does our weight change? So we're seeing as our inches increase, we see an increase in pounds. So as height increases, weight is going to increase. So how can I interpret that with this number of 9.2763? So we are going to think of this as, in terms of rise over run, to think of it as change in y over change in x, if you've ever seen this little notation here. So we're going to make it just as simple as possible to think of it as a fraction. You are going to think of it as 9.2763 over 1. So as x changes or increases by 1 unit, by 1 inch, so as our height increases by 1 inch, our weight is going to increase or change by 9.2763 pounds. So this is what we can visually think of our 9.2763 as being. So when I write this in an equation, or in a sentence, I'm going to write the following. For every additional inch of height, so every inch of height we add, we predict. So predict is important because this is going back to our regression equation. It's a prediction. We predict that the weight will increase or decrease. In this case, because our slope is positive, it's going to be increase by 9.2763 pounds. So for every additional inch of height, we predict that the weight will increase by 9.2763 pounds. If our slope was negative, we would predict a decrease in whatever our slope is. And we always would write this without the positive or negative there. So the increase or decrease word is dictated by the sign of our slope. Now, we can do something similar for y-intercept, and you can think of the y-intercept in the following way. The y-intercept graphically is what we have when we take 0 to be the x value. We say, what is the y-intercept going to be? So, in this case, we are going to think about it and is 0 inches, if somebody is 0 inches tall, we are going to predict that they weigh negative 454.12 pounds. So in sentence form, what this is saying is when someone is 0 inches tall, we again predict. So predict is really important, that the weight will be negative 454.12 pounds. So this is going to be our interpretation of y-intercept. Now, you're probably saying, Mr. Malo, somebody can't be 0 inches tall and they can't have negative weight. And you are absolutely right. So unlike the slope, which is going to make sense always, or should make sense, the y-intercept does not always make sense within the context of your situation. Sometimes it will, sometimes it won't. It will be up to you to distinguish when it is something that makes sense and when it is not. It does not make sense in this case. But this is generally how you are going to interpret your slopes and your y-intercepts from your least squared regression equation. So, I hope you found this video helpful. If you did, consider smashing that like button and subscribing, and have an awesome day.